My name is Melissa Brown, and I am a fifth grade teacher at West Hills Elementary School, and I have the honor of being able to walk through and do some scientific learning with you today. Before we begin, I just want to say how much we as teachers are missing all of your giggles and your smiles and your warm hugs. We hope that you're using this time to stay safe and stay healthy, and that we get to see you again very soon. Let's hop into some learning. First thing that we are going to talk about is the resources that are available to you. Resources that you can use to go along with the video sessions that we are creating. And there are two places that you could get these. You can get these from the Knox County website at knoxschools.org. Or if you're like me and you've probably run out of paper at this point, you can pick up printed copies from the food distribution sites on Wednesdays from 10 until 12 p.m. And if for some reason you're not sure where your nearest food and packet distribution site is, go ahead and hit up that Knox County website. Now, if you need a little extra time processing information, or maybe English isn't your first language, we have some strategies that you can use. And these are some simple things that you can employ and go ahead and help with the learning and the comprehension as we walk through this content. First thing, if you've got closed captioning available, turn it on. It's great to be able to hear me as well as see what I'm saying at the bottom of your screen. You can always slow your playback speed down. You can chunk these videos. No one says you have to watch them all at one time. Chunk them, watch a little, pause, listen, think, continue to watch again. Or my favorite, and this is what we do at home at the Brown household, is we watch them together. So I've got a third grader and I have a first grader, and we watch them together, and we will pause partway through the videos and we'll talk. What are we hearing? What are we understanding? Are there questions? So we've got some great strategies that you should be able to utilize. Now, on to the fifth grade science. If you're watching this, you're in fifth grade, whoop whoop. You are focusing on science, which is a whoop whoop. And today we are going to be working on week 3. So you are going to be kind of unique in the situation that we are going to piggyback off of week 2 and use it as a springboard for our learning and activities today. So what we're going to be able to do today is we're going to discuss adaptations and variations in living things, and we're going to compare and contrast them. What make them beneficial? Are there ways that are maybe not benefiting us in our environment? We're going to take a look at some images and some data and some resources. We're going to analyze that. We're going to make some inferences and connect it to some of our prior knowledge and maybe some of our prior experiences. And then a second part of our session, we are going to become birds, and we are going to utilize different kinds of beaks to scavenge for food. And then lastly, you are going to design your own bird that has to be able to thrive and survive in its own very specific environmental scenario. So you'll need a couple of things for today. First thing you will need is your fifth grade week 2 science packet from last week. And that was the one that was focusing on finches. If for some reason you did not do week 2, do not worry about it. We're just going to roll with it. We will have plenty of information and foundational info that we can lay for you, and we can move on. If you have it, great, grab it. If you don't, like I said, don't worry about it. As we move through, we are going to collect some other materials that we will need to do parts 2 and 3 of our activity. Now, let's jump into review. What are adaptations and variations? How are they related? Are they the same thing? Are they different things? Well, they are different things, and variations are just differences in appearances from inherited traits, all within a similar species or all within the same species. So first thing that pops to mind is that I think of eye color. We've got blue eyes, we've got green eyes, we've got brown eyes. If I'm connecting to myself at home, I'm thinking about the hair texture. I have very coarse hair and it's thick. My husband doesn't have much hair, but it's thin and baby fine. Well, my kids, I've got one child who's got thick, coarse hair, and I have another child who has really thick, fine hair. So those are all variations within our hair texture in our family. Another quick example would be watermelons. Love watermelons this time of year. And we can have two different types of variations. We've got watermelons that have seeds, and we have watermelons that do not have seeds. Let's hop on over to adaptations. Adaptations are related to variations because adaptations are variations within an organism that makes it better suited for its environment. So the goal of each living thing is to thrive and to survive. If you are not surviving, you're not meeting your basic needs. You're not getting your food, your shelter, you're getting picked off as prey, right? And if you are not thriving, you are not being able to reproduce and pass along your genes. So some adaptations that we might see would be, if you take a look at the giraffe, the length of the neck. That adaptation allows them to grab trees at the very top of the trees. It allows us to grab leaves at the very top of the trees. Take a look at the seahorse here. We can see that the seahorse has adapted by changing its coloration. The coloration here, it's very beautiful. It's speckled, it's colorful. And if you look at the background, the environment that it lives in, it's ideal because it's not going to be as easily spotted and picked off as prey. One quick thing that we need to mention about adaptations. Adaptations do not happen overnight. These are variations that are going to occur over maybe tens or hundreds or even thousands of years. We can break adaptations down into two different categories. We can discuss adaptations and classify them as physical, or we can classify them as behavioral. If it's physical, it's going to consist or relate to the physicality, the physical makeup of that living organism. And if we classify it as behavioral, we're going to classify how is it acting. And we have had to adapt with our behavior when we have gone from our classic traditional classroom setting to this distance learning setting, where in the classroom we know we raise hands, we ask questions, we know when and how to act respectfully, and things may have changed some since you're at home. So like I was saying, we can classify behaviors and physical adaptations in two different categories. And we are going to take a look now at this elephant in the picture, and we're just going to very quickly categorize. Is this a behavioral adaptation or is this a physical adaptation? If we're talking about the large veiny ears of the elephant, we know those ears are used for cooling and regulating body temperature. Would that be a physical adaptation or a behavioral adaptation? If you said physical, you are correct. Think about vocalization. Vocalization is just a fancy word for communication, right? Making sounds. Would vocalization be physical or behavioral? You said behavioral. You are correct. What about covering its body with dirt? Would that be a physical adaptation or would that be classified as a behavioral adaptation? That one would be considered a behavioral adaptation. The elephant is spraying the dirt over its back to protect its physicality, to protect its skin from getting a sunburn. Now, I just want you to think about the large padded feet. What would we classify that as? That would be a physical. The tusks would be physical, right? And the movable trunk would also be a physical. So very good job. We are now going to jump into our week 2 packet. All right, so I want you to take a look at pages 3 and 4. 3 is the page that has the picture of the finches and what they eat and where they live. And then page 4 is going to be part 3, and that's the inference that you made. So I'm just very briefly going to discuss the inference with you and see if we overlap, see if there are places that you and I agree on these adaptations and variations, and see if there are things that we may be different in our scientific thinking. So if you take a look at that first finch, the large ground finch, we can see that this finch eats mainly large nuts and large seeds, but it also eats some large insects. Well, I know when I'm thinking about if I'm eating large seeds, what am I going to need to get the flesh on the inside? I'm going to need something really powerful, really strong to crack that outer shell. Well, that's what I'm going to get with that large ground finch's beak. You can see that it's large in size, it's really thick, and it looks very powerful. Now, if I flip on over to the green warbler finch, this finch is going to be eating small spiders, maybe some small seeds, some small insects. Well, his beak is obviously not going to need to have the same type of functioning, so it's going to have to adapt somehow to a different type of food source. Well, this food source, like we said, small insects, small spiders. So my beak needs to be something that's small and that I'm easily able to navigate in and out of smaller spaces. So you can see out of these 4 pictures, they all have beaks. They all have variations of a beak, so they all look a little bit different, but each of these beaks have been adapted in a different way depending on what this finch needs in order to survive for its food source. So hopefully we saw a little bit of overlapping there. Now we're going to get into our first activity, which we are going to become birds and we are going to scavenge for some food. But before you do this, you need to make sure that you stop and you ask your parents for permission, or your guardian, whoever is at home with you, for permission to borrow some of these items. All right, you're going to need a cookie sheet or a Tupperware container, some kind of small bowl that we can spread this food out in. You're going to look for maybe some 5 or 6 small items that we can equate to bird food, and we'll talk about that in just a minute. And then we're going to look around the house and see if there are any small hand tools or pliers that we can use, or if there are materials that we can use to employ our engineer and design practices in, and if we can create beaks. So my food item collection, I used a cookie sheet and I just grabbed some simple things that were in our pantry. I chose some rotini noodles because I know that those rotini noodles kind of are about the size and shape of a caterpillar. I thought about the goldfish crackers, thinking about it's got a harder exoskeleton, softer interior. I thought about the rubber bands and cutting those apart so that they're kind of like smaller millipedes or centipedes. I found some different types of cereals, some dried fruit, and some straws that I'm going to cut up and tweak and put into some different kinds of scenarios, maybe different sizes, different lengths. And the zip ties, along with the straws, all have different textures. So I threw a little bit of everything in there. Now, let's take a look at our beaks. Again, I went ahead and searched for things that I really didn't have to create. I found some binder clips in my junk drawer. I went into our tool chest and I found some pliers, some needle nose pliers, which made me think of like a heron's beak. I found some leftover plasticware from a takeout food that we had. And what I did was I created my own beak with that. I found some tape and I taped the 2 pieces of silverware together, and I just wedged a piece of paper from my recycling can in between so that it allows me to open and close the beak. I did the same thing with some leftover chopsticks, but instead of tape, I used a rubber band, and then I just used the paper so that I can open and shut. All right, I want you to pause your video here and go ahead and see about some items that you can collect from your pantry or maybe around your house that we could utilize for beaks. Remember, ask first for some permission. Now that we are gathered back, hopefully you have your items. And if you see in my first picture, I went ahead and I did step 1 where I cut the food sources into various sizes, various textures, and I just kind of mixed it all around in the pan. I went ahead and I found my beaks, or I constructed my beaks that I'm going to utilize. And now you're going to take one of the pages from your week 2 packet and you're just going to flip it over and you're going to create a note taker of your own. So if you take a look at the bottom picture on my screen on the right, you will see that I just created a 5-column note taker, 5-column chart that I'm going to use as my note taker. And I'm just going to put some ideas, some thoughts, some observations that I'm experiencing as I go through with this next investigative inquiry. So as you do that, and as you are making your chart, I want you to, at the top of each of your column, go ahead and pick maybe 3, 4, 5, whatever you want to do, different beaks that you are going to label at the top of the column. Because underneath those beaks, like I said before, you are just going to list your observations and your experiences through your exploration. And as you go ahead and you try and pick up food and food sources with these different beaks, I just want you to think of a few different things. What is making it easy to pick up these food items? Are there some food items that are easier to pick up than others? Is there the design of a beak that makes picking up food easier, or a specific kind of food easier? How would these beaks be able to be navigated within your environmental setting? And what kind of food sources would you get? What would you be able to retrieve with a beak that looked like this? And then are any of your beaks able to maybe tear apart some of the food sources that you have on your tray? So go ahead and pause the video here, and we'll be back in a few minutes. Make sure you take some notes on your note taker and document some of your findings. All right, we are going to now put everything together. We are going to move on to our third activity, where we are going to put our adaptations and our variations together, and we are going to create a very unique bird of our own that lives in a very specific environment that I am setting you up with. So we know adaptations are all around us. They are just variations in living things that allow for thriving and surviving of this animal. And we know that when that animal is surviving, it's getting its basic needs met. And if it's thriving, it's able to reproduce and pass on those genes. We can break those adaptations down into two separate categories. We can say that we've got some physical adaptations. So think about the elephant's ear and using it as a cooling system, as well as behavioral adaptations. And those behavioral adaptations would be maybe the vocalization or the throwing of the dirt onto the elephant's back to avoid a sunburn. We're also going to hit on the variations where we can see that each of these birds have a beak, right? But these beak appearances are different. We have really thick, hard, wide beaks all the way down to a really thin beak. All right, so keep these things in mind as we move on to the next piece of our activity. This is going to be the beginning of our final element that we are going to be creating in this video session. So you can see that I have 2 columns on this slide. I have one column that is showing you beak types and talking about its adaptations and descriptions. And then I have one that is talking about the foot types of a bird and how those specific foot types, those variations, are adapted in such a way that it benefits animals by being able to swim or run or grasp. So for example, if we look at the very bottom and on the beak side, he's kind of my favorite. He's the Swiss Army knife. He's kind of like that jack of all trades beak type. So he has a multi-purpose beak that allows this bird, which our example that we have is a crow. It can eat fruit, it can eat seeds, it can eat flesh. So it's really an omnivore that can eat any of the above. And the stylization of this bird's beak, the adaptations and the variations allow it to be successful. We can also take a look at the probe beak in the middle there. So think about a hummingbird and that long, slender probing nose, and think about the shredder beak towards the top, where I think of like a peregrine falcon, or I think of a hawk, where it is used for hunting and tearing apart meat. So then we're going to take a step over to the right and talk about the different types of birds and their feet. Well, I know that if I'm a duck, I am going to need to have webbed feet, because with my webbed feet, I can go ahead, I can walk on land, but I can also paddle through water pretty efficiently. If I am a hunter and I have to get prey, small mammals, medium-sized mammals, I'm going to need something that is going to allow me to snatch or grab quickly. So if I'm a predator, I'm going for those grasping claws and the talons that are on the end. All right, just take another second and look through the different types of beaks and the different types of birds' feet. And we are going to move on to the fun piece. All right, here I have 5 different environmental scenarios that I have created for you. And in each of these environmental scenarios, I am telling you where this bird is living. I'm telling you what kind of foods this bird is eating. Is it an omnivore, carnivore? Is it an herbivore? I'm telling you what kind of activities this animal is doing or this bird is doing. So I need to really think about what kind of beak am I going to need so that I can obtain the correct type of food and I can survive. Now, what am I doing in my environment will make me think about, well, what kind of feet am I going to need? Do I live on land? Do I live in the water? Do I traverse both land and water? What are some very specific needs that I have? So with this being said, the bird that you are going to create can be something that is totally fictional, something that has never been seen before, something that is totally coming out of your brain and using your imagination. However, it could also be something that you read one of these scenarios and it kind of clicks and makes you think of a very specific bird. So I'm going to show you my example. I chose the purple box, which the description is saying that this bird lives in brackish or saltwater environments, can also live in marshes or ponds, is generally a carnivore, so that means it's generally eating meat and it's mainly consisting of aquatic animals or small fish, frogs, snakes, that sort of thing. It can also nest in treetops on the ground or in places such as duck blinds or bushes or mangroves. And this bird is also a bird that wades. So it's going to be able to walk through that water, and it's known as a silent striker. So when I drew my model, I went ahead and said, well, what am I going to need as a beak? What kind of adaptations am I going to need in my beak to make me a successful hunter of fish or aquatic animals? So immediately I went to that spear-like beak. And then when I was looking at a bird that is wading, I know that I'm going to have to walk through deep water, so I'm going to need very long legs. You can also see in my example that I went ahead and I labeled, good scientists label their models so that other people looking at them can know exactly what the scientist is thinking. So on the bottom here, you can see I've labeled that I have toed feet here and that each of my toes have claws on it and that my goal for having these feet is to grab prey. My beak is a spear-like beak that is well adapted for fishing. I have a long neck that is right here that allows for great movement or some of that silent striking, so I can move very, very slowly. But when I decide to strike for that fish or that prey, that I can strike very quickly. And then we know that not all birds can fly. My bird has wings and is able to fly, and this allows him to move both through the air and on land. So that you can see on the bottom of my picture here, I went ahead and I drew some prey, a little snake over here, and pretty thorough example of what type of beak do I need, because what is my bird eating? I've got to make sure that I am able to survive in that marshy or saltwater environment in those ponds or those lakes. And I need to make sure that I have feet that are going to allow me to traverse both in the land and also through water. So think about that as you go ahead and you pick your next scenario. Feel free to pick one. If you have extra time, pick a couple of them. And remember, this can be a totally fictional bird, something that you are generating all on your own. And don't forget to go back and reference our beak and foot page. This slide here or this page here will be tremendously helpful as you go ahead and you begin your creation of your very unique bird. So make sure that you're matching up. What is my bird eating? What kind of beak would be most beneficial? What kind of varied beak? And the same thing with your feet. How am I traveling? Where do I live? And how is this foot going to benefit me the most? All right, so we are coming to a close now, and we would love to see what some of your learning looks like. And we would love to make sure that you are using some of these strategies if some of the processing is a little bit more difficult. One thing we would like to do is we would love to be able to connect with you and have your learning shared here on our Facebook or on our Twitter handle, our Twitter feed. Our handle is at KCS Science. You can see it at the very bottom of the screen here. And it's a great way to connect with other students and staff throughout the county. We'd love to see maybe some of the birds that you've created, or hear about some of the learning and the adventures that you've had over this time period. But we want to say thank you for spending time with us this afternoon. We have enjoyed it, and we hope that you are all safe and healthy and that you continue living that scientific life. Have a good afternoon.